Hi, my name is Abu Bakr Ibrahim. I'm a third year PhD student. I'm working with Dr. Nandaria. My PhD project is searching for transient event and pulsar in multi-frequency data. First, I want to give an introduction about my topic, pulsars and neutron stars. What are pulsars? They are highly magnetized and repeatedly rotating neutron stars, for which they emit across a wide range of electromagnetic wavelengths. They are also classified in a number of classes, such as millisecond pulsars, rotating radio transients, and supernova associated pulsars. One of those classes is called magnetars, for which we are focusing on. They are isolated pulsars powered by the decay of their instability of their magnetic field. They have a strong magnetic field in a range of 10 to 14 to 10 to 15 gauss. Here it shows the pulsar, how it looks like. And here I'm showing the polar gap, which this is the model which explains the emission mechanism from pulsar. As we can see, we have the pulsar, the neutron star, these the magnetic fields, closed magnetic fields and open magnetic fields. Here we have the rotating axis, and here we have the magnetic axis. So the pairs of electron, positron, they accelerate across the magnetic fields and they emit in the along the magnetic axis. And all this system called a light cylinder, for which the light or the emission escape from the pulsar in the magnetic field. So the second, I want to just highlight that I'm working in a magnesium group, and within the multi-band group one, we focus in observation. More highlight about magnetars and their emission. And they have many emission activities, such as short burst. So magnetars emit short burst. They are most common type of magnetoradiative event. There are southern bursts. There are series of southern bursts. We have also giant flare. They call the queen of magnetars because they are very rare to happen. And they have peak of X-ray luminosities in the range of 10 to 44 to 10 to 47 hertz per second. We have the third one is Outburst. Here I'm showing a picture show that artistical review of their activities. We have Magnetar outbursts. They are large and sudden increase in the source X-ray flux in a factor of 10 to 1,000. Here I'm showing a photo of all the bursts until 17 from Suti Zilati paper. The plot shows the long-term curve of all the outbursts discovered up to 2017. We see a variety of behavior, and also we see a decay of the spectrum from the beginning of the outburst until the end of the outburst. My research project, what has been done in this past period, I have recently, I have the publication of the deep X-ray and radio observation of the first outburst of the Magnetar Swift J1818. In the project paper, I have used observations from XMM, Newton, NOSTAR, and Vela, and Swift telescopes to study the spectral evolution after the first outburst this source. I show in this figure the show I have the energy and I have the count. So this from 1 to 10 kilo electron volt is modeled by a black body with temperature of 1.1 kilo electron volt. As we can see here, I have the data. They are well modeled, and we have the here. I also studied the timing variability of this source, and we have derived a spin period parameter of 0.07 Hertz and derivative of the spin period of minus 2.27 multiplied by 10 to minus 11 Hertz, imply Hertz to the power 2, implying a characteristic age of about 500 years for this source. The result of this paper has been published, submitted to the BGA Data Astrophysical Journal, and now I'm implementing the referees comment for the final acceptance. is next in the following step. I'll be mainly focusing on the search of transient event and pulsar in archival data. These archival data will be collected from different instruments or satellites across all the wavelengths, as I mentioned earlier, from radio until gamma ray. This we perform developing a search code pipeline, which will enable us to perform a search for transient and periodic signals in these archival data. And in the later stage, also this project will all involve using learning technique to classify the object. And thank you so very much for your attention.